in surface area because what we do in surface area applies directly to volume. So today we're going to wrap up 13.1. We might dabble a tiny bit in 13.2, but I doubt it. Dabble, just a little. So we solved this surface area for my rectangular prism over here, and we found out that this was, who can remind me?
I don't know.
102.
That.
102 feet squared. We have to have our labels. And we solved that using the formula that was up our paper. So as a reminder, if you don't have these notated, highlighted, somehow sticking out on your paper, this formula works for any prism. Well, we need to remind ourselves, what is a prism? So what makes a prism different than other kinds of 3D shapes? Justin?
Just the two bases with a rectangle connecting.
So we have cloned or copied or same or identical or whatever you want to say. We have cloned shapes connected, which these are going to be our bases, connected with rectangles. So we have cloned bases connected with rectangles. Now this is our formula for a cube. And we talked yesterday, what makes a cube different than a prism? Well, it's still a prism. A cube is a prism. Just like a square is a rectangle. However, a cube is easier because every face is a square, and they're all identical. So, as we work through this, we're going to be using these two formulas. And there's a third way that we can solve this, actually. That will work with most prisms. It won't work with any prism. So we'll look at that on our last option here. So I want you guys, on your own for a moment, try the middle two here. We've got a cube and another prism. I want to see if we get confused. I will remind you, we're going to treat the bottom here as the base. So that'll be our base here. Here, we don't really care which is the base because it's a cube. So this is going to be special because it's a cube. We're only going to work on those two right now, so I'm going to kind of cross this out because we're not going to be working on that. Well, don't cross it out on your paper. Yeah, when I cross things out up here, it's because right now on my screen. Don't get a new copy. Just, you can still do it even though you kind of crossed it out a little bit. This is just up here because we're only going to work on these two for the moment. We're going to solve this one a different method. So actually, you can grab a Post-it or whatever when we get to this if you want.
It's pretty in blue now.
For my cube, I have an easy formula. Sorry, today I'm going cards too, because I want to see who's been paying attention, who knows what's what, and who needs some assistance. So, Mr. Walker, actually, sorry, I'm not ready for you yet, but I'm comfy. So, they use S. I personally don't like S for the same reason I don't like T. T looks like a plus sign. What could S look like?
5.
A 5. If you're not careful, your S's and your 5s get confused. So I would here rewrite your surface area formula as 6 times the edge length squared. And I'm going to notate that E equals edge length. So whereas S was side length, I can do the same thing with E being edge length. So here, what's my edge length, Anthony? Ooh, edge length. For here? Okay, how? That's exactly what we need to do. But what's our edge length? 3. So when we set this up, we have that surface area will equal 6 times 3 squared. And you already actually answered my next question. What does it mean to square a number? Yeah, times itself. Please be careful. Biggest mistake I see here, people multiply by 2. This is not multiply by 2. This is multiply 3 this many times. So So I'm going to have 3 times 3. There are 2 of them. What's 3 times 3? You already told me? 9. So this becomes 6 times 9. Which is 54 feet squared. Any questions on that? So now, try the third one on your own. I'm going to write some stuff up here. I'm going to write a lot of work. If you need, look up here, but I encourage you, try to keep your eyes on your paper. Try to solve this guy on your own. Remember, it's a prism, not a cube. My formula is slightly different. Perimeter of the base. If you forget any of this, scroll up in your notes. Lateral area equals perimeter of the base times height of the prism. This is why we have our notes. Thank you for asking that question. But always look back in your notes. Use your reference materials.
So do I, for me, would I have to watch some of the video to get caught up in the history up here?
You might want to watch a little bit. I mean, what we're going to do today is applying everything that you did yesterday. Like a little, because we only did like 15 to 20 minutes yesterday. So you didn't miss very much.
Okay.
So when I go to calculate my perimeter, CJ, my base here has what dimensions? 3 and 2. So to calculate my perimeter, do I just add 3 and 2? What do I do? So 3 and 2. If I add those, then I could either double them, or just add another 3 and another 2 for the back and the left. This comes out to give me a perimeter of 10. So I fill that into my lateral area formula. Then I need big H. There's a reason why we use big H here. Just
Why
trust
is
me,
that
the height
so
of the
big?
prism is big H. Justin, what is it?
4.2.
4.2. My man converted to a decimal. I love it. Because it is much easier to work with, especially since we have a 10. 10s make my life easy.
Okay.
What, Izzy, does multiplying by a 10 do?
You just take a whole I, but you just take away the 0 and then multiply it by itself.
So really, I love what you said, but really we just move the decimal. Multiplication by 10 moves the decimal. How many zeros is how far? So if I have 3 zeros, I multiply by 1,000, I move it 3 places. This is just 42. Any questions on how we got that? And I'm going to remind myself that is lateral area. I'm going to circle it because I'm going to need it. I'm not done, but I need that. Then,
She's gone.
I know, maybe.
Yeah, you're not here.
Lily? How do I find my big B? What does big B stand for? Base.
Base.
What about the base? Look on your paper. What's big B represent? We scroll back up. Look on our paper. 2 times big B. Well, what did big B mean? Area of the base. So my base, right there. My base is this rectangle at the bottom. So what do we get? 3 times 2 gives us 6. That's our big B. I'm going to need that, so I circle it. When I go to put it all together, I then, surface area, make sure you label, is 2 times the 6, the big B, plus my 42 becomes 12 plus 42 becomes 54 feet squared. I'm going to relabel that equals surface area. Guys, I need a level with you. This is not me as a teacher. This is not me as a mathematician. This is me from surviving middle school. If you choose not to write your work down and you try to just do all this pretty much in a
You're not going to know anything.
you are going to waste your time. I'm telling you, from the Accelerated 7 class that already did this chapter like a month ago, every time somebody would come and ask me for help, my first question is, okay, let me look at your work. Let me find where your mistake is. Let me find where you're stuck. Almost always. Oh, I didn't write anything down yet. Okay, go write something down, come back and see me when you hit your issue again. I'd go check with them in a couple minutes. Hey, you still need help? Oh no, I wrote out my work and I figured out my mistake.
He was guessing his answer.
No. Because we're trying to do it all in a calculator. There's too much. Look at all this. There's too much to keep track of. You cannot do this all in a calculator. You've got to write things down. This is why you're supposed to have a math notebook. Your formulas would be in there that you can refer back to. Your labelings of what does big B equal, what does SA stand for, what does LA stand for. All of that should be in a notebook. You can keep referring back to it. So this is your opportunity. Even if you haven't done it up to this point, you should have a notebook that you can keep your work in so that when you do work, it doesn't just get thrown away. Because the work that we do on tonight's homework might relate to the next homework. And some of the shapes will be the same. And if you can go back and look at the work you already did, you can save yourself time. But if you either did it on a calculator or recycled it,
Well, because
I guess you're doing it all over again.
well, you don't know what you did wrong if you didn't write anything.
Yeah,
so
you
you're
can't
just gonna
analyze.
Well, that means you're just gonna keep doing it over and over again. You're never gonna get the concept of it until you.
Or you just get frustrated and quit. That's the other thing I saw people do.
Hey, you're not allowed to quit.
Well, I know, but that, like, people, when they're not writing out their work and they don't know why they're getting
They're
things
wasting
wrong,
their time.
they get frustrated. So, on this last one, we're going to do this in a slightly different method.
Oh.
I see, to begin with, that I have all integer values for my edge lengths, which is really nice. I also see that because it's a rectangular prism, we know that the bottom matches the top, right? My bases match. But what else could I say matches? So I know that my bottom and my top match, so they're both bases. So once I find my big B, I end up doubling it because I've got clones. I've got the same exact thing. Casey, what else could we say matches? So my big B on the bottom, this base, you can go ahead and shade, especially if you have highlighters, will match this. And we call them both bases, even though we have like top and bottom.
Face.
So, Casey, what if I color in my left side? Could that match with anything else? The right side, right? So in a rectangular prism, what I start to see is I actually have all pairs of faces. So my left will match my right, and then my front will match my back.
I like to call it the
So
face and the back.
let's solve our big B. Julia, what dimensions do I use for the base? Why I colored in blue here?
You do the
6 and 1. So I do 6 and 1. Big B is 6. I'll leave it there for now. Justin, for my red faces, my left or my right, what dimensions do I use there? 9 and 1, thank you very much. Which, again, multiplication by 1 is pretty easy. And Andrew, for my front face, what dimensions do I use there? Ooh, so the dimensions we used 6 and 9 to get the 54.
Ooh, that's a
Now, I have 2 of these, double it. I have 2 of these, double it. I have 2 of these, double it. we get 12, 18, and 108.
Oh.
When I have done that, 2, 4, 6 faces, I've counted for all of my faces. When I add this up, and I get 138 feet squared, I'm done. Depends on your brain. It's just another method. If you think that's easier, you can totally use that until you have an odd amount of faces.
Surfacing.
So, here's what you can do when you have an odd amount of faces, or any regular polygon. What's it mean for a polygon to be regular? Why is this a regular pentagon? Okay. So I can draw, I bet you know after I do this, I can draw another pentagon.
I know.
Shane? The side lengths are equal, and the interior angles are all the same. So if these side lengths are equal, what can I say about these rectangles?
They're all equal.
They're all equal.
Those
So if you have a regular base, this is not a regular base. My side lengths are not equal. If you have a regular base, calculate one lateral face and just multiply by how many you have. So other shortcut methods that we can use to get there. Now, this doesn't make this method better. I'm going to start right when the second hand gets to the 6, the 30 seconds. I'm going to solve this using the other method. I just want you guys to watch. To see, like, this is the process that we take. Whether you choose this method or the other method, I bet I can do this in under 45 seconds. So, when I analyze this, the first thing I have to decide is how do I start? I'm going to go ahead and say I'm going to start with my big B, my base. So I look at my big B and I say, all right, I have dimensions of 6 and 1. That must be an area of 6. I need to find my lateral area. That's going to involve the perimeter of the base. 6 and 1, 7. Then double it for your other 6 and 1. My perimeter is 14. And then the height, the distance between the bases, is 9. That gives me 90 plus 36, which is 126. I actually have 2 bases, because I have another one on top, so I double that. Sorry, not plus, that would be an equal sign. No time to erase. So that would give me 12, 12, and 126 equals 138 feet squared. 40 seconds. That's the other route. The formula method that's on your paper is just this.
That looked like crap if I wrote that in 40 seconds.
But as you practice, as you write out the work and gain understanding, that's how easy it becomes. Yeah, you could use that for any prism. This method works for any prism. So for the pentagon, for a hexagon, for an octagon, a nonagon, doesn't matter. Nonagon's 9, by the way.
Oh.
Doesn't matter how many edges when I do this method. So that method always works. Alright, let's flip it back. Yeah.
Octopus with 7 legs, or septopus?
Funny enough, it's a really ironic question to ask that. One of
Oh,
my
you're
students
ironic.
from the past who actually came in and sort of like student taught with me when she was at Windward, she has her own art stuff that she makes. She made this octopus like design, and one of the legs wouldn't fit anywhere. It didn't look right. So like she gave me this sticker, and then a few days later I texted her, I'm like, yo, your octopus is a septopus. And she's like, yeah, the 8th leg wouldn't work. But yeah, you would call it a septopus. Or like, if it had 5 legs, you'd call it like a hexapus. So actually, this octopus, yeah, you can, whatever. This octopus that I took us with the octopus.
Oh, I was talking to you about that in the beginning
Yeah.
of the year.
So that was from Sarah Sisson. She does her own artwork stuff.
Remember
So since all of us have the identical laptops,
Big potato.
I put stickers on mine so I know which laptop's mine, and I just put stickers on like
Dang
everything.
it.
As you can tell from my water bottles.
I
and
told you
whatever
it
else,
was
or my car.
I told you I was going to bring my
So,
computer, but I
Skip
didn't.
on down to here.
Crap.
A dotipus, a 10-legged.
I was thinking of 2.
It's even.
Oh, that would be a bipus. Bi means 2.
Tripus.
A regular polygon. We
Regular.
want to reiterate this definition that Shane told us.
Got to say
A regular polygon And we're going to use math words here. I was texting with one of your classmates last night, and especially as we get deeper into here, we're using math words. So instead of saying equal or the same, what's the math word that means the same? Starts with a C. It's
Congruent.
Congruent.
Oh,
So
see,
all congruent edges. So this equals this equals this equals. You don't need to notate all those, but that's what we're saying is that all those edges are equal.
edgy.
Now, we have a few different ways that we could solve polygons. One way is cut it in half and deal with it from there. So I look at only the bottom part. Don't draw this. Sorry, don't draw this part. I could then chop off this triangle, bring it over to here, and I could make it into a rectangle. But there's a lot of things that I would have to do to figure out all those details. I'd have to figure out what is that length. I need to know this. I'd have to do some movement. And then still I've got two of them, so that's kind of complicated. I could leave it chopped in half and treat it like a trapezoid,
And then just
where you've got two different sized bases and you know that these lengths are the same. Or the easiest way that will work with any regular polygon to find your area, please write this out,
okay.
is the number of edges I'm going to run out of space. I'm going to shift this down. You can write it wherever you want, but I'm going to run out of space. Number of edges
Just put the sign for number.
Oh, yeah.
times area of triangle.
There we go. That's beautiful.
One property of a polygon, a regular polygon, is that I can draw lines, as shown to you here, these dotted lines, from a vertex through the center and hit another vertex. And if I do this from every vertex to vertex, I end up seeing, I've actually broken my shape up into 1,
6
2,
areas.
3, 4, 5, 6 triangles, which match how many edges that I have. So if I can calculate the area of one triangle,
Just multiply it.
all I then have to do is multiply by 6.
Yeah.
Now, we need to remember, how do I deal with a triangle? Well, that here would actually be, okay, we have 6 edges. It is a sexagon or a hexagon.
Excellent.
Times the area formula for a triangle is 1/2 little b times little h. You're gonna want this written down. Now, where are my little b and my little h? They're parts of the triangle. We are going to look at this bottom triangle. I'm going to capture this really quick. I'm going to erase this with space. If I look at this bottom triangle, this right here is the base of the triangle. It would be beneficial for you to notate that the base and the height are perpendicular. What does it mean to be perpendicular? Abby?
Doesn't perpendicular mean that they can intersect at some point?
They intersect at a right angle.
Yeah. That.
So my little b is just how long your edge is. My little h, please draw this, is the perpendicular right angle height from the edge to the middle. That is not, give me your eyes for a second please, that is not the same as this. These are two different things. This length and your height are two different things. So your height, you have to know that vertical or that perpendicular. But what's really nice is to find your little b and little h, all you have to look for is a right angle symbol. So as we go back up and look at our triangular prisms, that's what's going to tell us where's the little b and little h. They have to be connected at a right angle. Questions on this?
Oh, I remember doing this in 6th grade.
So Misadventure was on her trip. She brought back a block of cheese.
Oh,
Whoa.
Now we have to determine first what kind of prism is this. Now remember, to be a prism, I need a shape cloned to itself, connected by rectangles. So you need to realize rectangles are often going to be the lateral faces around. Izzy, what kind of shape is this? It is a triangular prism. So my big B, I know, is a triangle. I've got a triangle on one end, a triangle on the other end. So when I start looking at this and I start to calculate my big B, so my triangle is my big B. So to find big B, please write this work out. I'm going to need to use the formula for a triangle. Please write the formula. The more times you write it, the more you remember it. Don't put numbers in yet. Just write 1/2 little b times little h.
oh, little bit.
Here's Joe. Do you see a right angle symbol in my image?
Yeah.
What two lines, what two lengths is that right angle symbol connecting?
10 centimeters and 14 centimeters.
So this 10 is the base of our triangle because the base has to actually be a triangle edge. And this perpendicular line off of it, little b, little h.
Good morning,
Little
Caleb Smith. Please come to the office. Caleb Smith to the office, please. Thank you.
Wait. Why do you call
Instead of
little?
14.2 from the front, now we have 14.1.
Why do you call little b and little?
Because big B represents the area of the base.
So
Little b is an edge, is a length.
Okay.
Little h is height for the triangle. Big H, you might want to notate this, is the height of the prism. Little h, height of the triangle. Big H, height of the prism.
Oh, so that's the difference between triangle and prism.
Between what?
The triangle, the single triangle and the prism.
Yeah. So I could look at just the singular triangle. If you looked at only straight perspective and couldn't see the 3D, I have base, height, right? But then, as I turn it, I'm like, ooh, oh, it's 3D. I still have base and height, but then I have a new height, so I have to give it like a new label. So I can either call it like H2 or H of prism, or we just change lowercase uppercase.
Okay.
So that's the easiest way. When you get up into like high school, you'll start to use subscripts. So instead of little h and big H, you might say H1 versus H2. These are two different things because this is the first height, that's the second height. We don't use those yet. So I do this math. 10 times 14.1, I'm going to shift my decimal. Then I'm going to have to cut it in half.
That's not more.
When I get that big B is 70.5. And I'm going to circle that because I'm going to need it. I'm not done, but I'm going to need that.
Capture that in. Oh, the bean.
Bella, if I look at trying to find the perimeter of the base shape,
Right there.
right there. I'm not crazy. So, Bella, if I look at the perimeter of the triangle, do you have all three edge lengths for the triangle? And they're kind of in weird places.
Yeah.
What are they?
6.5.
Ooh, does that actually relate to the triangle?
Oh, no.
That 6.5 is actually the big H.
Oh, big H.
You'd have 10
Yeah, so this is part of my triangle perimeter.
and 15.
Yep, this 15 relates to this edge, and this 15 relates to that edge. So my perimeter, you can just jot wherever, is 15 plus 15 plus 10, which equals 4.
Yeah, that's
We then, Abby, what do I do with that perimeter working towards my lateral area?
I don't really know what to do. Okay. So, don't you
What's my formula for lateral area?
lateral area is the perimeter times big H.
So the perimeter times the height of the prism.
I definitely remember
I know my perimeter is 40. The height of my prism, remember, height of prism is distance between those cloned bases, right? 6.5 in this situation. 40 times 6 is 240, plus another half of 40 is another 20. So we get a 260. I'm going to relabel that that's my lateral area before I circle it so I don't forget what that is. You can never have too much clarification. So I had LA over here, but I remind myself, oh yeah, that's LA. Justin?
So we'll multiply that by 2.
Not the LA.
Oh, no.
If you want to check your formulas, the thing that multiplies by 2 is your base. Because when I look at my triangular prism, right, so if I stood it like this, triangle on bottom, triangle on top, sides, right, or side faces. When I look at lateral area, that has taken the prism, unfolded it, and said, okay, that perimeter, that was this. Because it's the distance all the way around the triangle. When I fold this back up, that's the distance around the triangle. When I unfold it, it becomes the length of the rectangle. The height is the distance between the two triangles. Are you cool with that?
Yeah.
Why are those E's capital? Looking at the actual prism.
Because it's big.
So big B is area of base. Is base area. So this 70.5, that relates to this. That's that space. Right? That is 70.5. So I have that one. Then I have these three. Make 260. Then I still have this guy. This one was 70.5. These were 260. What will this be? Another 70.5. Because it's the clone of the bottom. So when I go to do final surface area, that's why we double the base and then just add in one of the lateral area. The lateral area already took all of the faces. So 2 times the 70.5 plus the 260. I already actually knew 2 times the 70.5. I had it out here. Well, I didn't write it out, but it was 141. Relabel SA, please write this down, equals 401 centimeters squared. Go ahead and try that next triangular prism on your own. You want to look for the little b and little h to be perpendicular to each other. Little b and little h need to be perpendicular.
I got it.
And actually, you don't have to use your formula here. When I solve this, I'm going to solve this sans formula, without formula. I'm not going to use any.
Oh. Okay.
Actually, for sake of time, who like is struggling when we use that formula that involves perimeter? Who's willing to admit that, yeah, that's kind of complicated? Combining multiple faces is weird. So what if we don't combine anything?
Oh.
What if we do everything piece by piece? Now, it'll take a tiny bit longer, but it'll make more sense. So, let's try this. If you took the back rectangle, where you don't know anything about, well, really you did, because it's the same as the front. So, let's deal with big B, because it's still our base. That's the only one that I'm going to double, because I know it's cloned. Now, Xavier, what kind of shape is our base? No, that's the bottom. Always look at the name of your prism to know what your base is. It tells me my base is a triangle. You remember the area formula for triangle?
Half half times little b.
Yup, half little b, little h. So Brandon, based off what we see in the picture, can you tell what the little b and little h are? How? And the height is? Because they are. Yeah, this perpendicular symbol right here tells you there's one and there's the other. My little b and my little h.
There's another one.
So I have half times 3 times 4, that equals half of 12, which I'm going to remind myself that's big B is 6. Now I'm going to have to color code here. This bottom rectangle.
What do we do about the other one?
We'll get all of them. The bottom rectangle, not our base, just our bottom right now. What dimensions is that using, Aiden? I'm almost through my whole stuff. Yeah. What dimensions is that bottom green rectangle use? 7 and 4. So I'm going to say, okay, 4 times 7, 7, 14, 28. I'm going to need that guy. If I look at the back, what dimensions, Jack, does that one use?
500.
Ooh, careful. That 5 is actually this.
7.
So how tall is the back part of the shape? 3. How long or deep is the shape? 7. So this will be 3 times 7, or 21. And then, this is really hard to show here, so I'm going to use a highlighter. This rectangular face that is like close to us, the one leaning on the angle, it uses this, which we kind of crossed over, right again? 7 and 5. So my area, I'll just choose a new pen color, I guess. Of that is 5 times 7, which is 35. So I currently have 1, 2, 3, 4 of my faces taken care of. What do I need to do to make one last jump to having every piece I need? Abby?
We need to do that last triangle, or like the last.
Do we
Two on the
need
side.
to do it? We know it. So with these 3 rectangles, I can just say plus 6 and plus 6. Because both of those triangles are 6.
Okay.
So if I want to make sure that I have all 5 of my faces counted for, rectangle, 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 triangle, triangle. Now, when I add all these up, I don't have to use a formula. All I did was calculate each face individually.
Okay, it's just like 12.
20, 40, 70, 8, 79, 84, 96. I believe, maybe.
You believe me?
Can somebody please add those and verify for me?
I will.
What's this?
Oh my.
We did. We had this 6 and this 6.
Adding that?
Yeah, so we had 28 plus 21 plus 35 plus 6 plus 6.
96.
All of them together come out to be 96.
Oh, my name just popped so low.
Check it. I do make mistakes.
It is.
Sweet. Questions on that one? So here's my challenge, and you guys actually have 2 minutes that you can go ahead and start the challenge. You've got a big gap between when I'm going to see you again. So 13.1 is live. You can totally do it. It's available for you. If you have questions, please reach out to me. I was FaceTime with somebody or not FaceTime. I was Google Hangouting with somebody last night, and it worked really, really well because we can screen share on Google Hangout, so it's just like we were face-to-face talking. Because I can point to things, I can draw on things. So here's my challenge. Or if you don't even know the challenge yet. These 2 hexagonal prisms we are going to pick these up next Monday when we meet together, and we're going to solve these. If you choose to solve them on your own, and you step up to the challenge, and you bring me your solved problems before we have class, really, we need to be like first thing on Monday, because we have class pretty early, you will get a piece of candy. Or two, whatever. So, I don't think anyone's going to do this. I really don't, because you're all lazy. So I don't think anyone's going to do this. But surprise me. Step up to the challenge. Try your hexagonal prism. It's tough, especially since we haven't done it before, but that's my challenge to you. If you want candy, and depending on how many people do it, if it's like a few, maybe we do like a little pizza party or something for stepping up to the challenge. So I don't know, but I will tell you there will be a reward for those of you who choose to step up to the challenge. I forget your real name.
I solved it.
What is it?